Okay? So this is something that you can apply to mechanical things, electrical things. You can actually apply it to business process. You'll see that it's actually been applied a little bit to the chairman's team already. This is really the application of something that turns out to be common sense. But if you haven't seen it before, you may not realize that it can be done this way and can be structured. I use this in the work that I do at the University of Richmond. I've used kind of a broader version of this when I was a bank compliance officer as well at Capital One. Oh, by the way, I think you all know, but I'm Eric Palmer. Risk analysis. So who can tell me what's a risk? Define risk. Anybody? I want this to be interactive. I saw a hand almost go up.
Well, I was thinking about my answer.
Thinking about it, yes.
Taking a chance, something that could benefit you or hurt you.
Okay. Put it in the negative.
Death.
Huh?
Death.
Death?
Something that
All
can
right,
go
but
bad.
define it. Something that can
Anything that
go.
impedes progress.
Say that again.
Anything that impedes progress.
Anything that impedes progress. An occurrence, an event that can have negative consequences on desired outcome. So in terms of the positive, you can take risks, but if they say taking risks, those risks then imply there may be a negative to the risk. Hurricanes, great example of a risk. We could have a project and the project schedule could be disrupted by a hurricane. All right, veterans, who remembers the snow? Right? And that's a risk. So, who can tell me what a mitigation is? Anybody know that word, to mitigate? Yes.
It's like to minimize it, right?
To minimize it. To lessen the chance. That's exactly right. What's a contingency?
A plan in case something goes wrong.
A plan in case something goes wrong. So a mitigation is to lessen the impact or the probability or both of the risk. And a contingency is what to do in case it goes wrong. So here is somebody with a little snow plow, because we don't need big snow plows in Richmond. Is that a mitigation or is that a contingency? Speak up.
Mitigation.
All right, I heard mitigation and I heard contingency. Explain mitigation in this context.
It might be a contingency plan, like if you had a snow blower. But
Okay.
it's to mitigate, I think it's just mitigation because it's acting after the fact and just with a little shuffle.
All right, so mitigation is beforehand.
No.
Okay.
No.
Contingency is after. Contingency is what you do after, what you're ready for. Mitigation is what you do beforehand. So having that is a snowblower, believe it or not. In Blue 31, having that is in fact mitigation. He had that already in case. The contingency plan was to blow the snow out so we can get our car out and come to robotics practice. But in this case, it's both. So you're overrun. Okay? Failure modes and effects analysis. This is a tool that's typically, it's a form of risk analysis and risk management, but it's focused on either process management or on engineering processes, like a robot and operating a robot. Some definitions, I'm not going to read these to you directly, but you can look at it. I also have a few copies of the presentation, you can get more. But a failure is what we're first concerned about, and that's a risk. What can go wrong? And then what is the effect of a failure? What would happen? So who can tell me who was at Champions last year? What are some of the things that went wrong with the robot? Everything.
The transition from autonomous to teleop, right?
The transition didn't work. I think there were some loose wires at some point. Did any bot fall in? Once you know that something has occurred, then you should look for the cause. And then you should look for a way to lessen that likelihood of that cause coming into play. So loose wires, what can you do with loose wires in the future? Glue them in, solder them, use better connectors. What can you do before you run the robot? What was that? Cast? Check the wires. Have a checklist. Go through it. Get screwdriver tightened up, right? Benefits of FMEA, safer operation, less failures, and reduced impact of failures. So benefits of this is a successful run. Completing it all the way through instead of having the robot die on the field. So we just talked about electrical connections. There's one that's broken off. You could use a connector board, make sure they're screwed down. You maybe put some Loctite on it. How can we apply these principles to our robot? Well, you can apply it all the way from design to the end of the season. All the way along, you can apply these principles. And at the end of the season, you can do lessons learned and document what went wrong and what we can do next time to keep those things from going wrong. So Murphy was an optimist. What can go wrong will go wrong. So that's kind of in the mode of what this is about. To make things more reliable, you have to slow down to speed up. You've got to stop and say, what can go wrong? What's gone wrong already? What do we know from last year and the year before? What do we know from FTC? Document those things, and then look to preventing them from occurring again. So all the way down, all through here, there's things that you can do. So what would be something that you could do when you unbag the robot? So does everybody know we literally put the robot in a bag. What, 2 weeks and 3 days? Bagging, they call that bag and tag. We put a tag on it, sign it, log it. Why do we do that? Everybody know?
We have to stop working on it at the end of build season.
We got to stop working on it. That's the end of build season. So we transport the robot to VCU, get it in the pits, and we open the bag up. What's something that we can do to make sure the robot is reliable right after we unbag?
Run a systems check.
Run a systems check. What else can we do? Have a checklist, check for cords falling off, check for loose nut wires, those things. So there's a lot of tools that you can apply and techniques. The first one is, I'm going to move over here, is to make sure that we're all responsible for thinking more in an FMEA approach and take ownership. You could even have a reliability captain or reliability manager assigned on the team that leads that process. You can institutionalize this as a way of doing business. The better teams, the world champion teams that go back and win at champions again and again, I can guarantee you they use this. The teams from Detroit that are really super, that are sponsored by the automotive businesses, use this. So we should institutionalize it. You can perform root cause analysis. You can go to Wikipedia to get some help on what that is and how to do it. You can brainstorm at the beginning of the season, failure potentials, and then all along the way, you can brainstorm those. You should document actual and potential failures and the controls to keep those from happening. All right, and you can determine mitigation and contingency actions. You can use guiding principles in your work, which we'll talk about in a minute. Use checklists. And at the end of the season, do a lessons learned. It's not working. Failure. Failure.
Contingency plan.
Let's try this again.
Are you mitigating?
Keyboard is like, it's an, all right, so
Lessons learned.
this Mac is 3 years old, it's my work Mac, and this Mac was made for 2 months, my Macintosh, and we replaced it because it was such a bad design. So, here we go. All right, so I was there. All right, so you could have guiding principles. You could have guiding principles around commercial off-the-shelf parts. What might be some guiding principles for the parts that you use? What about C-RIOs? If you have one C-RIO, is that enough? No. What happens if it goes south? If it dies? You're dead. So you can, first, one guiding principle might be to buy the best quality part that the team can reasonably afford. Have spare parts, electrical. If Patrick was here, I know he'd have a lot to say about electrical, and I know a lot of you probably have a lot of things to say. But make all the screw terminals where you can get to them, so you can tighten them. Have screw terminals or have solder connections. Have a nice design board that's well laid out. You can have guiding principles that will help you have your robot be more reliable. Yes, sir.
And write down the connections.
And write down the connections.
So if you take it apart and put it back together, you can put it back
That's
together
right.
safely as
You can have guiding principles around mechanical, around tournament prep, how you train each other. You can live FMEA as a way of life around robot build season. Did you want to add anything more, Hugh? I actually determined that Hugh, back here, Hugh Gallagher, actually used this with, was it with the Navy?
With the military. Military goes in, obviously, in general, which is why you have $600 hammers and $10,000 coffee pots, into very in-depth analysis on failure modes and effects, reliability analysis, maintainability analysis, availability analysis. So, but no, you're touching on all the highlights, right?
Yeah, the same thing is used at Dominion with nuclear plants.
Absolutely.
That's right.
When the earthquake hit in August,
Yeah, better be, yeah.
when the earthquake hit at North Anna, the nuclear plant in August, there was a really in-depth analysis to figure out what happened. I mean, obviously the earthquake happened, but there was a bunch of people that analyzed how did the plant shut down automatically, and did things happen the way they were supposed to.
Right.
So pretty interesting.
So we had a project in Capital One where the bank regulators were asking us to make a change that required us to write custom software and install it in a branch in the Boston area. And it was in the August-September timeframe, and we did risk planning in the summer in July before we knew how we were going to write the software. And one of the risks that we came up with is our work could be disrupted by a hurricane. And guess what? We had a hurricane and power went out. And so you can't really mitigate a hurricane. You can't keep it from happening, but you can lessen the impact. And so we had mitigation strategies and contingency strategies. And one was everybody had 2 laptop batteries. And we would immediately congregate at one person's house if there were power failures, because we were trying to talk across phone lines and internet lines with syncing up the software. We all got together, we finished the software in time before our batteries died, and we made it to Boston to install it because the banking regulators could have cared less about a hurricane. If we hadn't done that planning, we would have been out of compliance and we would have been fined. That's a real practical example of risk management. Questions? Thank you all. Appreciate it. Hopefully we have some. Actually, one more thing. Pass out. I have some copies of the presentation. I'm going to give them to Coach to give to folks this afternoon. That
Do you have a digital version as well that we could use?
Yeah, sure. And all the pictures in here are open source or whatever, Creative Commons, and they're documented, so this one can go online. Here's if you guys could pass these spreadsheets.